Welcome everyone to this meeting of the Muswell Hill Sustainability Group. My name is Alan Morton. I'm one of the early members of the Muswell Hill Sustainability Group and its community energy. And of course, as you all know, Energy Limited has some solar panels on the roof of this very building. So you're benefiting as we speak from the activities of the Sustainability Group. It's my great pleasure to introduce Dermot Barnes and Josie Evetts, who are going to speak to us this evening about home retrofit essentials. Dermot is going to speak first about some of the practicalities, and then Josie is going to talk about the work of Ecofurb, which can give you advice about how to go about it. But she hastens to explain she doesn't have a lot of technical details at her fingertips, so she'll tell you how to go about it, but Dermot's the one that's going to talk more about what you need to do and how you start. So, and after they've spoken, we'll have a session of questions to both of them, and we'll aim to finish by about 9 o'clock, formal session with tea and biscuits. So without any more ado, I'd like to hand over to take us through home retrofit essentials. Thank you.
Thank you for the introduction, Alan. I'm presuming this mic does the job. Okay, thank you. So welcome everybody, and thank you for coming out on a not too cold evening, but soon to be very cold. And yeah, it's great to see so many people here today. Am I in the right place? You direct me otherwise. I've got, I need to ask you to move the slides on, is that right?
No, if you press the right hand button, it should.
The right?
Here on the seat.
Sorry, you'll need.
Yeah, that's okay. You can use the right arrow. It should.
The right. I've done that a couple of times now. It doesn't seem to be doing anything. Sorry.
That's probably
Oh. So yes, I suppose just by way of introduction, it's great to see so many people and to see so many people online. I'd like to just ask, before we go too much further this evening, we are facing a social justice crisis, we're facing an energy crisis, a food crisis, a financial economic crisis, a biodiversity crisis. And it's great to have people here who know about this, but there are many people who don't know about this well enough, the work of MHSG and what we're doing. So I'd just like to ask everybody this evening to just do one thing, just another person of the sustainability group and the work we're trying to do to support fuel poverty and people addressing these issues. So that's my one ask of you. We do everything that we're doing this evening voluntarily for the community, but the feedback and the response, the return for us is to see more people here and more action being taken to climate, to a crisis, and help people pay their bills. Great, so hopefully we're in gear now. We are. So in terms of this evening, I'm aiming to speak briefly about the UK context, some regulations, and essentially get into the meaty stuff of energy and buildings, and what are the key things we need to be focusing on. I'm going to introduce what I've been doing over the last few years. And I should actually just do a very quick introduction of myself for those of us here who don't know me. So I've been part of MHSG and Energy from pretty much day one. I also have run a company for about 12 years that delivered over 600 retrofit projects throughout the London area. And I'm also engaged at the moment as working for a design consultancy in London who are delivering retrofit on a large scale for social landlords, various borough housing associations across London. So quite a lot of building fabric, kind of getting things done, construction experience, as well as some of the engineering modelling that goes behind it. So that's me in parenthesis. So I will talk from my experience, case studies, and tell you how those have gone and how they worked. I'll speak about retrofit methodologies, by which I mean some of the kind of frameworks or approaches people can use if they want to retrofit in a joined-up thinking way. About the key elements within buildings and how you can try to address them. So we'll start with lofts and roofs. We'll talk about floors, walls, and we'll also talk about heat pumps. So the sort of main aim of this evening is to give you some takeaway information around the key energy consumption patterns in your home and point you to the immediate, the more strategic things you can do to get a kind of a plan together to make your home kind of ready for the future as well as the present. So I'm going to start with a couple of brief introductory points so people get the context, the sort of global context as well as the UK context. So this graphic is from a 2017 Bayes report that talks about energy sector emissions across the UK. The thing that's important for you to take away from this is that we're running at around about 30% of emissions through residential buildings in the UK. So there is no net zero UK as per the Climate Change Act of 2008 without addressing one of those elephants in the room. Now, when we do address the elephants in the room, we turn first to the National Grid are the people who design and deliver our electricity. What they're saying, this is their recipe, and they're saying there will be no net zero until and unless these. Now, some of these things border on fantasy, if I'm honest. Some of them are practical, some of them just have to be put down there, they have to be aspired to. So 2.6 million heat pumps. We've got, I think you'll see from a slide a little bit later on, about 12,500 in the UK at the moment. We need an extra 912 megawatts of solar. And this is the thing, extensive retrofit. So the third element here of extensive retrofit is the crucial thing, which I'm going to come to. We then need thermal storage, which is meant, by that we mean ways of storing heat and energy so that it can be captured when the energy is available through solar or other renewable sources, and then used when it's needed, because there is often a mismatch between those two things. And that lead ingredient in the recipe, which is smart demand supply matching. What that basically means is you use your appliances when the energy is available from the national grid, not when you feel like it. And if we are to get to net zero, one of the things that's going to happen is you'll be told, not asked, but told when you should run your appliances. And I don't think it'll become dictatorial, but it'll become you'll pay 2 and 3 times more to run your dishwasher or your fridge or whatever. Your fridge is clearly on all the time, but any of your voluntary use, you'll be given price advantage if you use it at the right time. And this is already happening. So Octopus Energy already this week announced that they are going to start a scheme, possibly as early as January, whereby anybody who is on their tariffs will have the opportunity to be compensated for, i.e. paid, for running their appliances, certain of their appliances at certain times of the day compared to other times of the day. So there's 3 inevitable things that stem from this. The first is, net zero means gas grid connection to your home in the future, unless you're living in a particularly rare and incredibly difficult to treat home where there are no other ways of serving it. It's unlikely you will have a gas grid connection. 60% of the energy you're using at the moment has to go. You just have to find ways to use 60 to 65% less energy, which is, what does it mean? Does it mean I run my heating system, my hot water system for, 7 or 8 hours a day compared to 24 hours? There are all sorts of serious implications, and these things will follow. And a lot of people are making these choices anyway because they can't afford to pay their energy bills. But we'll move on. And then optimized energy, renewable, local, and semi-local. So moving on to this, getting into some of the nitty-gritty of what happens in your home and the energy that's being used. Now, every home is pretty generic extraction of what happens with energy use in the average home. And really, there are two key takeaways. 66% is for heating space, typically, and around about 17, sometimes a bit more, is used for hot water. Those are the two big elephants in the room. All the other ones are important, increasingly important ones, but it's these two that you've got to start with. So that's what we're going to focus on. Now, we just talked about the number one, 66%, being space heating. So this is a very solid indicator of how energy is lost in buildings, i.e. how heat dissipates through the fabric of a building. So if you think about it in the most simple terms, you're heating a cube, a container of some sort. You want that heat to side that thermal envelope outside, inside the building. You don't want to. Every element in the building has got a heat loss factor. Now, you probably can't read the percentages here, but let me read them for you. The roof, around about 26 to 30% of heat loss goes through the roof. So one of the super quick and easy, least expensive things you can do is insulate your loft well, and we'll come back to what well looks like. Approximately 33% of the walls. Around about 10% is through the floors, with windows and various drafts and what have you making up the balance. So is a key kind of go-to reference point for what to do in your home. You just think, hang on, where is all the heat loss going? Through these elements, therefore, I'll tackle those. So moving on, I'm going to speak through 5 or 6 slides here, which are social housing retrofit projects that I've been involved with, gracefully funded by national government and local government as a pilot demonstrator project to help other social landlords understand what's ahead and what have they got to do, what's going to cost, what the challenges are. So this is in London Borough of Sutton, where I led a 100-home project for. So on the left-hand side, you're seeing what it looked like before, and on the right-hand side, you're seeing exactly the same house after the event. So there were 2 sets of measures that we took. The first were the building fabric measures, which are all focused on keeping that heat inside the building. So once you put the heat in, it stays there and keeps you warmer for longer. And what it also focuses on is not losing, basically not having drafts, not admitting cold air into the building. So 2 objectives. Number 1, keep the heat in, and number 2, keep the drafts out. And when we talk about drafts, we're talking about uncontrolled ventilation, is the kind of nice way of putting it. All homes have to breathe, they have to ventilate, correct? You want that to be on your terms. You want to control it in a way that is balanced and appropriate and proportionate to the needs of the building and the people in the building, rather than just having holes all over the place where cold air comes through. So in terms of the measures that were adopted, I won't put the building here, but this was essentially a kind of post-war homes for heroes, lowest common denominator construction, cheap and cheerless rather than cheap and cheerful. And essentially you see kind of panelized posts, a concrete post and inside sort of bricks, so a cavity construction. But what we did, being very brief about it, a fill of that cavity. All the walls were filled with an insulant, and on the outside, as you can see, 215 millimeters of mineral wool insulation. So on top of the sort of brownish exterior, you get the white rendered facade and new windows and everything. But also inside the cavity, about 165 mil, I believe, of mineral wool insulation. So if you think about that, that's insulation. You're talking about that much, about 320 mil of insulation going on your walls. And a lot of us here don't have that luxury. We don't live in cavity wall construction homes. We live in solid wall construction buildings, in which case is really inside, and I'll come on to that in a little while. So all of the kind of fabric measures, the thermal envelope measures, were these ones. You know, the insulation inside the cavity and on the exterior, plus triple glazed windows and doors, and a new roof structure that went over the top, highly insulated and airtight. And on the kind of mechanical side, maybe four key things. Mechanical ventilation. I spoke briefly about the fact that all buildings have to breathe. If they don't breathe, you get rot, mold growth, you get fabric degradation, you get health problems for the occupants in the building. So the MVHR is a way of controlling ventilation into the building and not losing heat, because there's a heat exchanger on the fan which essentially captures the warm air in the air that's being extracted and brings that back in, mixed with fresh air. So you get what you need without losing is in the air. There was a very significant solar array, which you can just about see on the roof here. There was an air source heat pump, and I'll come back to what that is and how it works later. There was any gas ovens or hobs were removed and replaced with electric ones. And also, people forget, but we spoke earlier about 17% roughly of the average domestic energy bill goes into your hot water. So controlling the amount of water you need is important. So we changed all the tap outlets and shower outlets to make them low flow, so there wasn't, you know, gallons and gallons of water being wasted. Okay, now you're probably not going to read this. Apologies. It's put a little detailed. I'll probably go to one thing just to start with, is that when you measure the efficiency of a building in terms of energy efficiency, you measure it in terms of kilowatt hours of energy needed to do a certain job, and then you kind of divide that by per square meter. So to give you a UK home consumes in the region of 215 kilowatt hours per square meter per year, whereas the target here was 40 kilowatt hours per square meter. So pretty radical level of intervention to drive down the demand in the building. And then on my previous slide, we spoke about what the national grid needed. If I just go quickly back to that. We spoke here about extensive retrofit, and we talked about this figure here of 60 to 65% demand. Those things in mind, that we were retrofitting homes to make them, let's say, ready for decarbonisation. Because you can't decarbonise a home entirely at the moment. You can't go net zero if you're connected to the grid. Unless, of course, you've got some sort of special arrangement whereby renewable energy. And I say special because there's qualifications around that. But anyway, let me scoot forward again. So I won't bore you with the detail here, but just remember that 40 meter per year as a heating load. So in terms of what happened, this is the package of work. And I'm sure the question on many people's lips will be, how much did it cost? Everybody wants to know that one. So for a sum of between 80 and 95,000 per home, we carried out all those works that were described earlier, which is a colossal amount of money for anybody. But, you know, in terms of what it did, so we had these homes up with, remember I said it was about 250 was the average, 250 kilowatt hours per square meter. These homes, which are particularly poor, were just under 350, about 330 for the year before we started the work. And we were designing to that kind of level there. So you can see what we were aiming, what we started with, and there was a range. The worst performing unit had about 400, and the lowest had about, I think, 280. So, there was a huge order of magnitude change. And this one is, another measure of the same thing. I won't go into the technical detail, but it's there when you want to look at it. The slides will be available afterwards. And this is just, what it meant for tenants. So, these are the actual bills before and after year-on comparisons. And in simple, 6% reduction in heat loss, an 89% reduction in carbon, and a heat/electricity demand, which came down to an average of about £600, which was about 60% reduction on 2019 prices. Clearly, that's not the same world that we're in today. And this was another part of the borough, slightly different constraints. One of the things was we didn't have time to do a planning application, and the external wall insulation, the raising of the roof and putting solar panels on the roof in many parts of London are collectively or singly considered to require planning applications. And in this particular project, as a sort of small parenthesis, I would say there's a huge gulf between people who are operating planning policy and people who are operating net zero / energy policy in the UK. People haven't made the connection, and politicians don't have the courage necessarily or the skills to enforce the joined-up thinking that would make some of these things easier to happen. So long story short, we couldn't do external or internal wall insulation here. All we could do was cavity wall insulation, triple glazed roof, and we had a curious thing which I'll explain in a moment, a porch pod, and we also closed off the air bricks and provided a managed ventilation void beneath the floors. So just to think about that, we couldn't treat the walls internally or externally, and we couldn't treat the floors. So big you could do. We could only do the cavities in the windows and the doors. And on the mechanical, electrical, we also used a lot of solar, which you can see, and we used an air source heat pump with a heat battery, which is a little bit different to an electricity battery, which will store, it stores heat rather than collective electricity. And we also had a diverter which took some of the energy from that and put it into water store for the hot water in the house. And again, there was the same gas disconnect and low flow taps. Now, I'm going to move quickly on, mindful of time. When you start thinking about retrofitting in a structural way, let's say, in a considered way, it's really good if you can use a methodology. Now, why do we want to think about using a methodology? Because essentially we want to avoid consequences that are not intended. So getting things in sequence, doing the right things in the right order, will avoid redo things. So you do need to think sequentially, and this isn't necessarily a simple thing to do. So there is a methodology called the PASS, publicly available standard 2035, a PASS 35 methodology, which involves a number of people who will put together a plan which is based on the dwelling itself, individual dwelling, what energy it's using, where it's going, what the use of the building is, etc. It looks at either a range of immediate improvement options, but it also, and that's what's called a medium-term implementation plan, which basically means, you might do some things now, you might do some other things when you're changing your kitchen or your bathroom conversion or whatever in a year or 2 or 3's time. So, packages of work around around the life and use of the building. You might have patterns of use changing in the building with somebody moving in, you know, and kind of methodology tries to think about that. It tries to put a plan together that is joined up, minimize mistakes around the plan. So this is a national methodology which is available. It's mandatory for all social housing projects, so any publicly funded projects at the moment require this. And the same level of rigorous thinking should go into private homes when they're retrofitted. And you know, other than that, just go quickly back here. There's a range of different thoughts and different things that go into the equation. You know, there's building regulations. There's you know, the EPC and what it means. But these things are rather, they're regulatory, and they are well below the level of performance that we need to deliver at the moment for retrofit and net zero. So basically, if you're even vaguely serious about doing retrofit in your home, you'll be walking all over the building regs. You'll be exceeding them because they're quite low, unfortunately, somewhat tragically in my opinion, but anyway. Then, you know, there are other methodologies that you can use. The passive house method, which uses Retrofit as a way of refurbishing buildings in an energy context, provides methodologies, targets, standards, etc. And there's also an organisation called LETI, which is the London Energy Transformation Initiative, which has put together some freely available information around how you should undertake retrofit. So, I want to touch briefly on the materials you use. So when we talk about the impact, the environmental impact of the work we're doing, there's operational carbon, which is what's happening as the building is powered, but there's also whole life carbon, which is what happens to the building when it's built first, all the way through its operation and at its end of life. So in super simple terms, it means try to materials in the fabric, the materials and the palette of technologies you use carefully. You know, buy well, buy once, buy high quality, don't repeat, buy things. Better to wait until you have enough money to do the right thing, then do it well. Because the environmental impact of, you know, a constantly changing and a palette of materials is huge. And in many evaluations that are done at the moment, it's considered that the non-operational energy and environmental impacts is up to 50% of the whole life energy. So, you know, this is something to think about. And also, if you bear in mind, this is an example of things to think about when you're looking at it. So insulation doesn't just, it's not a commodity. Everybody wants to think, oh, I'll just go and buy some insulation. It's not. You need to use materials that will bring benefits to your building in the way you want them to. So yes, clearly you want to reduce the heat, the speed at which heat is lost, and that's what insulation does. But you also want to think about various other aspects of the equation, which will include how warm the building gets, how hot it is in summer, and has an impact on that. So you can use high-density insulation systems, which reduce the speed of heat gain in summer, whilst also acting in the same reciprocal way, i.e. stopping heat loss or reducing heat loss. There's also, you know, considerable sustainability impacts and a wide variety of different things. So not all insulation materials and not all materials full stop are equal. So it's worth asking yourself as you look at products, you know, is this a healthy product? What kind of damage has it caused to the environment already? What kind of damage will it cause in 10, 20, 30, 50 years' time? You know, and does it really heat my home in summer? My home stay cool. And overheating is a classic problem. So just briefly on this, the Climate Change Committee released a report this summer in July on pretty much, I think, the hottest day of the summer. I think they probably just waited for the thermometer to hit 40 degrees. And two sort of jump out points from that. The first is that by 2035, it is expected that we need 6.5% less energy for heating our homes, but 5% more for cooling our homes. That's with conservative climate change that we're already living. So based on 2018 modelling and 2020, which are the worst 2 years we've had in quite a while. But that's the new norm. We're only starting to see that. So that's an interesting and somewhat terrifying statistic, because it means we need to think. And there are, at the moment, I think the same report, yeah, pretty much 2,000 people per year are dying from overheating in homes. And that's predicted to double by 2050. So we have to think about, you know, heating and cooling of buildings. So getting into some nitty-gritty, which is, I guess, what you're all here for, lofts. These photos could probably do with being a bit lighter, but I think, Joyce, your home, at least one of these photographs is your home. So what you're seeing here is that the basic thing that you do. In between your joists, at ceiling level, you'll put 100 to 150 mil of insulation. Your joists will typically be 2 by 400 by 50. You'll fill that, and then you'll go across the other direction. And ideally, you wind up insulation, cozy all the way across the roof space. That is that if you need to store stuff, you're snookers, because you need to avoid compressing that insulation. And here you're seeing sheep's wool. There are lots of other products you can use. And in this loft, you'll see a rigid insulation board which sits above the joists. So just there, in that space there, is the top of the joists. So in those joists, you'll have some sheep's wool, and above it, you'll have 2 rigid insulation boards with some hardboard on top of it, as you see here. And there you have space you need for storage. Clearly, this option is much more expensive than that option. And there are other ways of doing this, by the way. This is just the least expensive and least environmentally costly way of doing it. For those of us who are living, after storage in the pitch of the roof, these are, example solutions of insulation in the line of the rafters. Now, super important point to think about this. If anybody offers to do this for you, release it very, very carefully. On most roofs, you've got to have a clear line of air running from the kind of gutter to the eaves. The eaves to the ridge. So that continuous line of insulation has to be maintained. If you block it up, you'll get mold growth on your joists. You have to control the ventilation. If you remember earlier, I was speaking about the ventilation where you need it, when you need it, not just willy-nilly. So this is one of the things you need to think about. You can insulate that void, insulate the void partially, run of ventilation, and you do something on the underside, belt and braces, to get a really efficient solution. So this is a floor. So you're seeing the floor joists here, and in between those floor joists you have a rigid or a semi-flexible insulation, and some means of carrying it. Normally you'd use a sort of membrane which gets stapled to the side of the joists and just carries the insulant. Now if you're doing a belt and braces and you're aiming high, what you'll also do, and this of course you'll have noticed requires the floor to be up. This is not the easiest thing in the world to do for everybody, but if you are taking your floor up, the thing to do is to put a membrane, an airtightness membrane, underneath, and then tape it to the edges all the way around the room. So if you remember earlier, I spoke about two things. I spoke of keeping the heat in. So in this case, the insulation you see here is keeping the heat in, but it's not keeping the drafts out. The only way is by having an airtightness membrane. Now, clearly, ramming that into every cubic millimetre of space is going to help with the cold drafts, but it's not going to eliminate them. So if you want to do it fully, this is the way you would do it, and then you go back. Now it shows, a floorboard flooring, not necessary. You could just go straight across if you wanted, but you do need to think about how you do it. Now the sort of straightforward approach is this. This is the cheap option, where you've got access of a kind of crawl space, and you just put lots and lots of insulation, and in this case I think it's like a bird mesh or a garden mesh just taped to the underside of it to hold it all in. It's going to make a huge improvement, but as I say, it's the fully rigorous approach. Wall insulation. How am I doing time-wise? Got another 5. Brilliant. Okay, let me run through. So walls. This was a project where it's a new build house. Now it's a net zero house, which we did, 15 years ago or so, 12 years ago. Cavity wall insulation, external wall insulation, plus triple glazing, plus solar PVs, plus solar thermal, lots of stuff, with a climate scientist who lived in the house and kind of knew the future. Not that it wasn't obvious to a lot of people back then, but anyway, he was tackling these things up front. Anyway, that was one approach. Now, in terms of a lot of details to think about, and again, you'll remember earlier I spoke about breathing buildings and the choice of materials. So a typical solid wall building has to be able to allow the moisture that builds up from human activity inside it to get out. And if it doesn't do that, then you get mold growth and condensation issues. So what I would call a breathable insulant. So in this case, this is a wood fibre product, which then gets rendered to look like that. That's the same wall. It gets rendered with a lime-based, sympathetic to the building. This was I think this was a home in Walthamstow. It was end of terrace, 1890s, 1880s, kind of late Victorian, I think early Edwardian. And that building will have been a breathable building from the beginning. It has terracotta bricks or fire clay bricks, and it has lime mortar originally. So using sympathetic materials to the building type helps. Plastic on the side of that building, and by plastic I mean petrochemically derived insulants. It's going to behave differently, so you have to think about how that works. So moving on, when you do look at external wall insulation, this is an example of a survey we did for Haringey some years ago, where we were just looking at properties, and here you see huge amounts of obstacles. People who have taken routes over time to take all the kind of I suppose all of the conduits going in and out of the building would just happen to be on that side of the building. Important, plumbing, electrical and drainage adds enormously to the cost of doing external wall insulation. So you're in a lucky situation where you've got almost a blank canvas of a wall. Just, thank God for the fact that you do, because it'll be a damn sight cheaper to do this work than it will be. Take a project like that, which will cost about 150, maybe 200 pounds a square metre to do external wall insulation, and you can add 50 pounds a square metre to it and more if you need to muck around with all your drainage, and that can be several thousand pounds on its own easily. Internal wall is the other way of obviously tackling buildings, even more important from a breathability point of view. There's a point where water vapor condenses. It's called a dew point, and it's super important that that's on the outside of the building, not the inside. So what you're trying to do by using natural insulation is make sure that its way to the outside of the building and doesn't get lost somewhere in the middle and cause problems. So anyway, this is an example of internal wall insulation, again with a lime-based plaster. This was a tongue and groove of boards. And you remember earlier I spoke about air tightness. So there's lots of this kind of insulation above this. You can see some of it. And then there's an air tightness membrane, which is taped and sealed at all the joins, which essentially does the business of controlling the amount of air that gets in and out of the building. So heat pumps, a finishing point. Very quickly, everybody wants to know, what should I do? There's several issues to think about, and I'll come on to them in a moment, but a couple of realities. These various pieces of data here come from various government policies. Earlier, I think I spoke about the recipe from National Grid being 600,000 heat pumps per year by 2026. 1,000, I said 12,000 earlier, apologies, 22,000. It's, the rate of increase is just ridiculous. I don't know how we'll ever get to 600,000 without radical change. It would require a 30-fold increase. Now, that said, and this here is a reflection of the number of people that it's going to take to deliver that 2026. So, just looking briefly here, in 2035, it's estimated, if I can read it, 63,000 installers will be needed nationally. And in 2019, we had 200 in the country, qualified installers for heat pumps. Now, that is increasing, and there's more demand for it. So it's not so bad today as it was, in 20. So here are my golden rules, if you like, for a heat pump. If you live in a house, you're very lucky if you live one as beautiful as this, but if you live in a house that's a solid wall building, you're going to have lots of fabric heat loss problems, the stuff I was talking about earlier. So in order to put an air source heat pump in, I advise very, very strongly one of two things, and ideally two of two things. The first of those is some of that boring insulation stuff I talked about, heat demand down by 60%. And ideally, add a solar PV array to it. And even more ideally, add a battery with the solar PV system. Only then, when you've got those two ingredients, at least those two ingredients, should you have a heat pump experience, you'll otherwise wind up paying an awful lot more for your energy. And that's courtesy of the mismatch between gas and electricity prices, which is being theoretically addressed by central government, but don't hold your breath, is around about 4 times more per kilowatt hour than gas. So I think that's me. Yeah, it is. So I think what we're going to do is to have joined up questions afterwards. Josie's going to speak a little bit about some of the assistance that can be provided, and then we'll do the questions Q&A afterwards together. Should I give you? Shall I hand this over to Josie, or turn it off, or?
Yeah, certainly. I hope. Oh, that's what's good. Right. Can you hear me now? Yes. That's much better. Hi. So my name's Josie. I work for an organisation called Parity Projects that I'll tell you a little bit about in a minute. A service called Ecofurb, together with another organisation called Retrofit Works, who I'll also tell you a little bit about in a minute. So I'm not going to talk for a very long time. I'm going to try and keep it simple. The idea of setting up this service was that we wanted to provide something that did make retrofit simple for people who get advice and have to hold their hand through the process, because it can get quite complicated. I suspect I'm in the room full of people who are actually interested in the details than the average person, so it may be that you do want to get to grips with all the nitty-gritty, and actually it's really good if people do then understand what their installers may or may not be including in quotations and things like that. But obviously a lot of people, the time that it takes, the hassle, etc., barriers to actually getting on with it, and they'd really like to have somebody, an advisor there to sort of help them through some of that. So that's the idea behind you set up in the first place. So Ecofurb, I should say, is at the moment only running in London, but that's all right for you because you're all in London. Ecofurb was born out of two organisations, Parity Projects and Retrofit Works, winning some funding from central government to run a pilot. There were 6 of these pilots across the country. Didn't reach the end of the sort of pilot period. We were all trialling different things, different approaches to making this a sort of simple process. And the other 5 are all sort of running in one way or another in different parts of the country now. And Ecofurb's the London pilot. And so we launched about 1.5 years ago, and are run by Parity Projects, the organisation I work for, and the sort of bread and butter of what Parity Projects does is software in order for landlords, local authorities and others to look at their housing stock and calculate energy use and how to retrofit those buildings, or create strategies for whole areas as well. So it's sort of really the quite detailed, and that's also been made into a tool that homeowners can use that's sort of on in it. And so that's a sort of a way that a homeowner can look at their own house, and it's actually free to use. And you can look at what, whether sort of this type of installation or that type of installation, or how much it might cost, and what would suit your particular home. So that's what Parity Projects does, mainly, is create software. And we partner together with Retrofit Works, actually set up by the same director. Retrofit Works is a cooperative of installers, other retrofit professionals like retrofit coordinators, and also advocates, so organisations like Muswell Hill Sustainability Group. So people who want to make the retrofit easier and more prolific around the country basically come together as members of Retrofit Works. Retrofit Works has been working in the grant-funded sort of arena for many years, about 12, and very, very successfully doing a lot of retrofit in that way. And it's quite recently been working together to try and get a different type of market moving, to the non-grant funded market. And that's actually been, in many ways, maybe slightly counterintuitively. So, moving on. As Dermot's already actually said, all homes are different. It looks a little bit like this is an area of housing. I can't remember where it is actually, but it's where our director's grandmother lives. One of these houses is hers. So these are actually real houses, and they're showing how the energy is used in each different house. And you can see they're all really got very different makeups. So we wanted to create something, a service that would address that actively. And this is the so-called customer journey that we've come up with. So you have the first step, which is to, you can do that online for free. So what we want to do is create something that you can use any part of. So you could use all of it or just any part of it. So you can use just the free tool online, look at your home and see quite a lot of information about how much it costs, how much energy you might save, how much money you might save doing retrofit. And then you could go off and use that information yourself just to have a better start. Or you could then invite a retrofit coordinator to come round and do a version of that, but obviously a more sort of you can do online, and have a whole house plan, which Dermot was talking about before as well. Part of the PAS 2035 framework that Dermot was referring to is that you should have a phased plan for your home, and we produce those if you invite a retrofit coordinator to come round. So that's stage 1, which measures suit your home best, basically. Stage 2 would be if you wanted to carry on, and not everybody does. Some people take that plan off and they go off and do it themselves then. Stage 2 would be to actually put some detail behind that. So you could ask us to produce a building performance requirement, which is something that helps the contractor to quote for the right things rather than make details, and also to make sure that different contractors work together. So if you're having external wall insulation done at the same time as windows, there's a certain order, again, as Dermot said, that you would want to do that in, and considerations that you need to take into account. Make sure that that was all looked after. Stage 3 would be to go on and actually have the installation done, and again, if you carry on working with Ecofurb throughout, you'd retain a retrofit coordinator who would come in and look at the install as it was done, look at it when it's finished, and sign the work off. I'm just going to grab a drink of water. Some of you will have seen this slide before. You've been to other Muswell Hill Sustainability Group events. Customers like these are one of the reasons why we wanted to go for that government funding and set up a service like this, because parity projects used to provide advice to homeowners, but didn't through to the supply chain, find the builders for people. So these particular people, they were really, really pleased with their retrofit in the end, but they actually had quite a different. So they're very, very pleased with the advice, the sort of whole house plan element that was given to them. But then they found their own contractors and didn't go so well. And we had that happen quite a number of times. So that was a very sort of strong reason why we really wanted to be able to link through to install, say these installers know how to do this. In case, we're going to check it and sign it off as well. So that was JP and Gabby. So just to take you step by step through the stages that I mentioned, this is a screenshot of the plan builder. So you could go onto the website I've got there on the slide, and you can find that, click on build a plan, try our free plan build, and you can just go and have a play around yourself. Then you could ask for a retrofit coordinator to come round, and this is just one page out of the whole house plan, and you can see there that there are different phases. I think, yeah, that's right. There are different phases to the plan, so that would be based around several different factors. So what you're planning to do with your home later, and also something that we're going to start bringing into the phasing is that there are significant backlogs with some types of work at the moment. Some types of work are much easier to get done within the next few months, and some of them you're going to have to wait longer. Certainly in terms of the people we've got access to, we've got membership of that we'd be able to get quotes for things like cavity, loft, heat pumps, and various other measures, windows and underfloor, relatively, within a certain time frame. Whereas other measures like room and roof insulation that Dermot was showing on the slide there, and internal wall insulation particularly, that's not going to happen very soon through us. Our contractors just aren't available to do it. So we really, really sort of upfront with everyone. As soon as they start a whole house plan with us, we'd be able to explain to you the likelihood or not of being able to get estimates within a reasonable time frame. And unfortunately, they aren't as reasonable as we want them to be. So it's really important, basically, for us that anyone that sort of starts a journey with us has a really realistic, because I think it would be the last thing we want is people to start down a journey and then find that they're not getting where they want to buy. So one page out of the building performance requirement document, that tends to be helps your contractors quote in the right way. And then works, so this is one of the jobs that we've done. You would have the contract with the installer, the coordinator would come out during installation to make sure that it's all happening as per the building performance requirements, and then check the work and sign it off at the end. And so this is one of our customers that we've had since we've set up Ecofurb, and the thing that he liked best about the service was the flawless. He says, I don't really want to, I don't want to sort of think, well, are these people nice? Are they going to do it well? I'd just rather go to someone for me, and then can feel a lot more confident. So on the same website, just to show you where you can go in and access the plan builder and start the journey with Ecofurb if you'd like to. And that's the end of the presentation. And you can ask me anything about the service that we provide, also about maybe some of the difficulties in setting up the end-to-end service, because we've thought a lot about how to do that and what works and what doesn't. Anything technical, I think Dermot would be able to answer a lot better than me.
The floor is yours, so who would like to ask the first question?
Can we use microphones for the purposes of the live stream, please?
Yeah, okay, cool. Had a couple of questions. One was quite interesting what you had to say about the loft nation. I gather, I was wondering about the difference between ceiling and roof. It looked to me as though ceiling was actually better than roof, and that's what I've got at the moment. So do I need to look at roof as well? I don't use the loft space for anything other than storage. That was one question.
Dermot, sorry, can you use, you can take it off the stand.
Sorry, yes. So the short answer to your question is, if you can insulate adequately at 300 mil, you know, around a foot, at ceiling level, do that, and that'll be cheaper. The only reason to have to insulate in the line of the roof is for some other reason, and there's sometimes good reasons.
Okay, thanks. Floor insulation, I presumably you're only talking about ground floor.
So the greatest heat loss ground floor, but if you wanted to be really careful about it, you would also want to heat only the space that you want to heat. So yeah, when you're heating the living room, you don't necessarily want to heat the room above it.
Yeah.
You know, you want to use the heat in the room where it's required actually and there are acoustic benefits as well. So if you can do interfloor, but it would be right down the bottom of your priority list in terms of heat loss and money.
That makes sense. Heat loss just to even though the roof is insulated, and I don't heat the bedrooms because I don't like warm bedrooms, but so I'm getting heat loss presumably into my bedroom. Okay. And then finally, it was a question to Josie, isn't it? It was around suppliers, contractors. So I think 2 or 3 times that, you know, this is most of us who have had contractors in our homes find the same reliable people who are going to be pleasant to have in your house, but importantly will do good work. Now, one way is to buy your services using the online and then managing the project oneself. Do you provide lists of reliable contractors as well? Or is there such a list somewhere?
Hello. Currently, that's not something that we provide, and I'm sure that some people do. I'm not sure whether that's something that you...
Just to say that on the Muswell Hill Sustainability Group website, there is a list of contractors who are kind of tried and trusted, recommended by members, not necessarily by us individually. That changes obviously in company. You might not find all the services you want there. There's only some certain specific things there.
Yeah, I've got some detailed questions for it. No, I haven't actually. What proportion of the work you do on a house could you do yourself? Because we talk about contractors, somebody who can use a drill and a tape measure and can put up wall, like what proportion would you estimate? And the second, what proportion of the benefits do you think people could get purely by behaviour change? Shutting the windows, pulling the curtains.
Two really good questions. I mean, just tackling the second one first, behaviour change does make a big difference, absolutely. And there's some common sense things that everybody, and there are some low cost measures that people can take. And I believe we've got a session next, if not the week after, where somebody is talking about kind of low cost that can be taken. But, the behaviour cues around heating spaces that you only need to heat when you're going to be in them, balanced an understanding of the usage pattern in a home. So what often happens when you're heating your this is a bit of a rabbit hole answer, but if you heat only, if you have in a house, you'll find you use more. It's just like being in a car. You accelerate, you decelerate, it's more petrol than if you've got a relative, 3,000 revs all the time. It's exactly the same with your heating system. So a common sense principle would be to only heat what you need to heat when you need to heat it, but you have to think about that in reference to the fact that you're making. But silly things that make a difference, like closing your windows, not opening them as often as you might want to open them, getting fresh air at certain times of the day when it's not as cold, closing your curtains at dusk, shading your home. There are lots and lots and lots of common sense stuff, and any Google search will show you 20 pages worth of how to be clever with the smaller measures. Coming back to the question around what percentage of the work you can do yourself, it depends on who you are. It's an obvious question, an obvious answer. But a lot of people with common sense and some standard tools could do quite a few of the measures. And Stuart is a lot of these DIY things. And when he has done open homes, he shows you a lot of the work that has been like secondary glazing, insulation, that can be done with some common sense and a little bit of blood, sweat and tears, hopefully less of the former. But so there is quite a bit you can do. Things like external wall insulation, things that are electrical and plumbing related, probably best left to professionals.
Hi, thanks for that, it's very interesting. I mean, I suppose I have two questions. One is a practical one from Josie, which is that I have tried to use the online tool, but it comes out, it never manages to actually generate, even if I say I have an unlimited budget. So
it's still calculating.
So I'm not sure if there's the problem. And I'll just do the second one as well. I mean, I think the worry with a lot of this work is that you have the combination of availability of contractors, and then you have these long-term problems like where you might get condensation and other issues. And then also this, the people who will try and go for natural materials and the people who will sort of, polyurethane thing. And so it's getting that balance seems to be quite difficult, because even if you have got the project signed off at the end, if your problem starts in 5 years' time, when you realise there's damp, it's a bit of a worry.
So firstly on the plan builder, if you have tried that, if you can email us your address, to why it's not working and solve it for you, and hopefully then you can use it. And that goes for anyone else. If you do have any glitches with it, it does have glitches. It's relatively new, but it works for a lot of people as well. So in terms of the stylings down the line, when the particular example I think you gave was whether the right material was used, that's something that would go into the building performance requirement and be something that would make sure that for the right material in the first place. There wouldn't be someone there like standing over the contractor the whole time, making sure that they're not sort of being dishonest. That's not sort of something that would happen, but we work with contractors that we know and trust to do good work, and very often have been working with Retrofit Works for a number of years. And we do sometimes remove people as contractors as well when we don't think that they are doing work that's up to scratch. So.
Any more questions?
You were talking about walls and how much heat loss is from walls, but a lot of us lived in terrace houses, and I wondered, does that change the amount of heat loss that you get if you're living in a terraced house on both sides, so you're joined to other houses?
It absolutely does, and when you're in a situation where you're mid-terrace and you've only got a back wall to worry about, that is going to be depending on the scale of your ambition, you would tackle the front and the rear walls. And what you'd also do, because it's very common sense, it's a scientific approach. You measure how many square meters of how many different materials are involved. So, quite a lot of houses will have about a third of their wall elevations will be glazed, sometimes more. So you have to think about the glazing and think, is that the better thing to spend the money on? Or so there's lots of things to think about there. And my talk this evening was deliberately not jumping into windows, because it's another subject area really. But just a kind of parenthesis to that, to say that if you are really aiming high, also need to be treated, because there is heat loss. Now, there's heat gain as well from your neighbours, so you might check out your neighbour's boiler temperature, before you insulate the wall. Ask him, excuse me, should I spend 20 grand, or will you just heat my house for me? See what he says. But yes, there are those considerations, and in some of those social housing retrofits that we were showing earlier, one of the conscious limitations we had, because we were actually aiming higher, in terms of we want to get down to about 30 kilowatt hours per square meter per year, but there were two things we couldn't do. One was the floors, and the second was the party walls, because we didn't want to the property. We wanted it to be a lived-in property all the way through. So yeah, that's a qualifier to terraced houses.
And is cork a good insulator?
Cork is a good insulator, and it breathes. The material thicknesses and the build-up need to be thought about, and how again, it's how much what your targets are. A wood fibre board, which is made up of concentrated post-sawmill waste as opposed to cork itself, often has a higher performance, and it's just very real. But each material has its own application, and cork is definitely a good one to look at.
Can you say what that was again? That was better than cork. Sorry. Can you just say what that material was again?
So wood fibre insulation boards made by a variety of different companies. One of them is called Pavatex, P-A-V-A-T-E-X. But there are lots of different companies that make them. That's kind of a post-sawmill waste product, which is very dense and very effective.
Which is a bit better than cork. That's good. Yeah.
Yeah, and it comes in thicker pieces.
Got another one. Thank you. Actually, what I wanted to Brendan, is it Brendan? Dermot, sorry. Was you mentioned something, and I just wondered if you explain explain it. When you said no air bricks but managed ventilation instead, that's new to me, because I thought, we must never cover the air bricks. So what did you mean by that?
So I don't advise blocking up air bricks. Underfloor insulation needs a lot of careful thinking to maintain the right flow of ventilation, but at the same time you need to address the heat loss. So in this particular case, the design included a sealed underfloor space, but with an extraction, a humidity activated extraction fan, which circulated cool and fresh air into the space and took out any moist air through the system. So therefore, if you did have any sweating occurring, for want of a better term, any moisture buildup, it was being pulled out by a humidity stat, activated fan system.
Is that what passive house principles are?
Well, Passive House generally recommends the use of that kind of technology amongst others in a suite of measures to deliver an ultra-low energy home. Yeah.
Thank you.
Hi. We've got a Victorian terrace with original 2 bedrooms in the attic, so it's a Victorian attic with little dormers that's clearly not insulated at all. You can feel how cold those are. It's all wood chip wallpaper and everything else, but people live in it. We can't think. Is there a way of putting something over that rather than ripping out all the old and insulating, which sounds very disruptive and messy? Can we put something on top of that to keep disruption down?
You can, and the key thing is, there's a general principle with all building interventions, and that is you don't want to make a situation any worse than it might already be. So if you were thinking about avoiding taking down ceilings and just trying to put something underneath, the first thing you would want to do is get somebody to drill pilot holes and use a thing called a boroscope. It's a camera on the end of a flexi stick which goes into the space just to check that there is adequate ventilation and no fabric degradation. So in other words, that the ventilation is working as it is. Assuming it is working and that you don't have any issues, and you would need multi-point interventions, holes, top and bottom, to check ridge to eaves in several different places in the loft. Then you could put an insulation board on the underside of the existing plasterboards. You'd want to make sure that the surface of the existing painted plasterboards is open, vapor open. So in other words, sometimes they get painted with an oil-based paint, and if it is just wood chip with emulsion, you'll be fine. But if there's an oil-based, then you might have a problem. So you need to make sure that it essentially keeps, and you use an insulant that will allow some of that moisture to just pass out the way it has been over time. Now there's lots of different boards and you don't have much space to play with, I imagine. So you have to choose a high performance product, and it depends on how much pitched roof space you have before your head is going to hit the space. Typically you'd add about 50 or 60 mil using, or even more if you can get away with it. But in which case you need to use another kind of product, again making sure that that is a vapor open product.
Thank you both very much. I was just wondering about, obviously there are a lot of different materials available and with varying properties and varying eco-credentials. And in terms of with the Ecofurb process, is that recommendation on what type of materials to use, is that something that you would advise on, or it's a conversation between you and between us and the various contractors that you might suggest?
So your retrofit coordinator would be able to advise on which types of material. Would certainly have some materials that they would recommend that contractors do sometimes standardly use. So.
Yeah, thank you both. Really helpful. This is a question I probably should have asked Stuart, who kindly opened his house this weekend. And I would point out that the problem himself is much, much greater than the proportion I might be able to do. But it's a very simple question, which is, what's the situation with regard to the requirement for planning permission for solar panels in Muswell Hill in the conservation area? Do you need it? No, that's a different question, I suppose. Is it law?
I honestly don't know. I mean, you could ask, and we'll just do it. Yeah. Are we seriously, Haringey's declared climate emergency? Are we seriously to come after you?
As somebody who's got solar panels in a conservation area, it can be done. As somebody with solar panels in it can be done. I think there's a presumption in favour of it, but obviously you'll just have to ask. In terms of the Muswell Hills, in Tenergy's PV roofs, we've got 2 on schools and 1 on Marks and Spencer's, 1 here. And I don't think in any case did we have to ask for planning permission. Okay, time for one final question before tea, or is it this gentleman again? And if there's no other questions, we'll go for tea.
Yeah, mine is just sort of trying to make sure the clarity about slightly contradictory things. So you talk about the importance of having a membrane to avoid all drafts, but at the same time things need to be breathable to avoid moisture. So how do those two things fit together?
Yeah, I'm not a scientist, so I can't give you the fully technical understanding, but there are things called intelligent membranes, and essentially they're vapor open on the inside to allow a certain percentage of moisture to evaporate through, to percolate through to the outside, whilst being kind of air closed on the outside. So they work as a breathable solution, preventing maintaining the air tightness of the building whilst allowing it to breathe. That isn't every membrane that Joe Soap and Co. Will turn up to fix to your house. You have to specify and or check, which is to some degree the job of the retrofit coordinator to make sure that the materials are going to do the job that they should do, they're designed to do. But it's always worth checking. Sometimes because in innocent error, the wrong thing turns up on site, and so it's always worth checking.
Yeah, I think you can get lost in the complexity and the detail here, because we open our house, and then I asked a lot of the time, I look at people's houses, and you go in the front door, no disrespect, but you don't need a retrofit coordinator to tell you that the door doesn't close properly. There's actually a gap at the bottom of the door. Your letterbox is stuck open. Your windows don't fit properly. Before you get to doing this, a lot of people have, it's not rocket science what you need to do. A person could do themselves.